Hello everyone, welcome to this another video of data structures and algorithm series. This is the second video. So today we are going to cover analysis of algorithms and growth rate. The subtopics we are going to cover in this video are why to analyze and compare algorithms, time analysis, list of commonly used growth terms, types of analysis, and there are further subparts in types of analysis. So let us begin without wasting any time. So the topic number one is why to analyze and compare algorithms. So we'll understand this with an example. So let us consider we need to reach this location, this flag, right? We are in space. So what do scientists do? They make a spaceship to reach that destination. And obviously they find the best path to reach this flag is the straight line. So while analyzing the situation, they found that there is a meteor in the way that is waiting for them, right? So this algorithm was not perfectly suitable for them. It Although it was the shortest algorithm, but they did not analyze the obstacles in their way, so they did not reach the final destination. They could not solve the problem. So what they do is they take some another path, and that is this path, right? So when they take this path, they reach the particular location they wanted to reach, right? So now we get the reason number one to analyze an algorithm. That is, we need to analyze an algorithm to find the solution of a particular problem, the best possible solution, right? So, although your algorithm is this algorithm is the shortest way to reach the location, but you are not able to reach your particular destination by using this algorithm. So, this is not the algorithm you want to use or you will be using, right? So, you get the reason number one to analyze or compare an algorithm. Here comes the second reason to analyze an algorithm. So, again, you want to reach this flag, this particular location from this car, right? So we don't have any obstacle in the way. So the first path we used for the spaceship was this path, I believe, right? And the second path was this path. So now in this problem, we need to find the shortest and the easiest way to reach the particular location. So the first path you chose was obviously the best path because it was the shortest. You saved more fuel, and it took less time. So this is the need you need to compare and analyze in algorithms. From the two algorithms you find, the first one was better because you could reach the destination you wanted to. It was the shortest possible path you could take to reach the destination, and plus points you're saving fuels and memory and much more, right? So now let us talk about time analysis, right? So, as the name suggests, time analysis is something that is used to analyze time a problem is taking. As the size is increasing, how much more time a particular problem will take. For example, let us consider an array. So, what do we need to compute is as we increase the size of the array, how much more time will the array take? So, the next topic we are going to cover is list of commonly used growth terms. So before diving into list of commonly used growth terms, you need to know the basic definition of the rate of growth, right? So let's ignore this bookish definition and understand this with one example. So let us consider there are two boys. This is boy A and this is boy B. And you need to compare this as you need to compare these boys to some algorithms. Like this is one algorithm and this is a second algorithm, and they need to pick up this box. So the algorithm A or the boy A and boy B takes the same time to pick this one box up. So till now we know that they take same time to pick up the box, right? Now we take a second box. Now this time the boy A takes the same time as he was taking to pick one box up. But if we switch to boy B, he takes double the time he was taking to pick one box up, to pick these two boxes up together. So as a result, we find out the rate of growth. So for boy A, the rate of growth is constant till now, right? Because he takes equal time to pick both the boxes up. But if we switch to boy B, in his case, the rate of growth doubles up till now, or it is A plus A, I mean A plus A means if we consider this box as small a, or this time to pick up this box is small a, so it takes 2A to pick these two boxes up. So if we add one more box, we notice that boy A takes a bit more time, a second more, to pick all these three boxes together. So now we have a rate of growth for boy A's time also. Is not constant. And for boy B, he takes triple the times. So as the size is increasing, they're taking more time. It maybe they take constant time, but yeah, they're taking more time. So this is I hope you understand now what is the rate of growth from this particular scenario. So now we are going to talk about list of commonly used growth terms. So while analyzing a problem in algorithms, you will come across this list very often, right? So the list is here, like 1 log n log n square n cube 2 raised to power n. So what basically is this? Here n is the input size of the problem. So the function of 1, you see, it remains constant, the first row. So it means as the size increases, it takes same time, it takes constant time. So it has no particular growth rate. It is taking same time. But if we talk about log n, as the size increases, it takes more and more and more time. And if we go to n, it takes uh, time equal to the inputs, right? So this is the increasing order of the time they're taking, right? So you'll come across these problems in your data, in algorithms and data structures a lot. You need to choose the best possible algorithm which takes the shortest time and lesser memory to solve a particular problem. So I hope you're understanding what I'm saying. When you put this value 1 in this log n, you get 1. And you don't need to worry about the base. Here they're taking the base as 2. So for 1, log n value is 1. For 2, log n value is again 1. For 4, log n value is 2. And for n, you are already clear. And if you solve n log n, for 1 it is 1, for 2 it is 2, for 4 it is 8, for 8 it is 24 when you solve. And here also you need to do square of the input sizes. So these are some commonly used growth terms in which in which your algorithm may grow, right? So I hope this is clear, and if not, please comment below. I'll be telling you, and I've also mentioned my ID in the description box. So let us go further. So types of analysis of an algorithm. So you can analyze an algorithm in three ways, and that is the worst case scenario, the best case scenario, and the average case scenario. If I talk about the worst case scenario, this means what size of a particular problem takes the maximum time, what input size. I'll be explaining this with an example. First of all, understand the definitions. Best cases, what input will take the least time for an algorithm. And average case is very simple. You need to add or time taken by each input divided by the total number of inputs, like the average name suggests. So this is an example. Let us consider this is an array and you need to search some element in this array. For worst case example, what will be the worst case in this array? If you will be told to find 18, that will be the worst case. Why? Because for that it will take maximum time. For that you have to go to this member. You have to check if it is equals to 14 or not. Then you need to go to, if it is equals to 18 or not. Then you need to go to the next element. Then you have to check it is equals to 14 or 18 or not. And you have to reach till the end. And that is why it takes maximum time and it's the worst case. So what is the best case here? I believe 14 is the best case here, because you'll find the element in the very first position. You don't need to take a lot of time. And talking about the average case, you will need to add the time taken with this. By if your search result was this, you need to add the time taken. If your search result was this, then you need to add the time taken to search this. and you need to add the time taken to search this, and so on. You need to add all these values and you have to divide it by the total number of inputs, that is 1, 2, 3, 4, 5, divided by 5. So that is what an average case is, right? I hope you get it. So that is all for today. Hope you enjoyed the video, and if you find it informative, please give it a like. Do comment below and tell me if there was any problem, and don't forget to subscribe my channel, and I mentioned my email ID below, so if you have any doubts you can email me there directly. And thank you for watching. Goodbye.